Good afternoon, everyone. We are Group 116. I'm Mickey, and this is my partner, Blue. It's our great honor to be here and present our Capstone project, the stock market reaction to global chemical disasters. Our agenda for our presentation today will basically follow like this and mainly cover 4 parts: the introduction, the methodology, the main findings, and then comes our final conclusion. Chemical disasters, as we all know, are one of the most destructive events that humans encounter today. In the past, we see the severe oil pollution in the deep water horizon. And we also witnessed the considerable evacuation and casualties in the Fukushima nuclear disaster. Last year, the horrifying Tianjin explosion brought those nightmares to us again and led to significant casualties, financial loss, and toxic release. So you may wonder why we care about the chemical disasters. So this is a distinction from other events, the toxic release. The toxic chemicals released by these chemical disasters could be in the soil, in the water, in the air, and everywhere. Even if the disaster occurred far away, it could still affect you. Affect the water you are drinking, affect the fish you are eating, and even affect the air you are breathing now. So people should care more than just the death pool of the chemical disasters. And we want to raise the public awareness of the toxic release impact of chemical disasters, which can be, in the longer term, larger in scale and more severe than we can imagine. So among all these impacts that could be brought by the chemical disasters, what factors are actually driving the stock market reaction? That's what we are interested in. So having done the literature review, we found severe drawbacks of previous studies. And overall, they were concluded with controversial results. So because of these reasons, we are committed to provide update and original evidence through our project. And also, we want to provide incentives regarding the preventive and remedial actions to both companies and governments. So here are the 3 hypotheses we proposed to direct our research. Large chemical events basically cover all these 3 factors. So we expect the investors tend to react based on the overall severity evaluation of chemical disasters. So here comes our first hypothesis. We expect that the negative reaction would be more stronger for the chemical accidents with high severity suggested by these 3 characteristics. And from our preliminary news research, we found an interesting fact that the chemical disasters occurred in developed countries tend to be highly covered by the media. So will this have any effect on the stock market reactions? According to previous research, the media coverage tends to attract the investor attention and then affect the stock market. So we expect that the negative effect on the firm's market value would be stronger for chemical events occurred in the developed countries due to such media effect. And our final hypothesis is based on the government intervention, which is likely to lead to significant and unexpected costs. Take the deep water horizon as an example. The US government undertook many actions towards this event, and one of them was a moratorium, which is to suspend the firm's operation. And this led to a significant decrease in the stock price. So we may expect that if the government intervenes the chemical disaster, this will bring a really significant negative effects for the companies involved. So I will hand over to Blue to talk about our methodology applied in our research.
Okay, thank you, Mickey. After deriving our 3 hypotheses, the next problem is how to test them. Unfortunately, there is no complete and updated list of chemical disasters that happened worldwide. Therefore, we have to use the news database called Factiva to manually search for the chemical disasters happened worldwide, basically over the most recent decade from 2005 to 2014. And the keywords we used are chemical plant and explosion. After screening thousands of global news, we got 62 serious chemical disasters that happened globally. And in order to investigate in the stock market reaction, we further filtered the cases and got 30 cases with listed companies responsible for the disaster. As you can see, most of the cases, almost 2/3 of the cases occurred in the US or the mainland China. And overall, these 30 cases covers 9 countries globally. So as you can see, some of the responsible parties are quite familiar faces, such as BP, PetroChina, Shell, and DuPont, and TAPCO. So using this data sample of 30 stocks, we applied the market model of the event study. And the event window is set 10 days before the event to 150 days after the event, so covering the short, medium, and long-term market effect. You may ask, why not only care about the short-term market effect? Because according to Bernard and Thomas, investors' reactions might be delayed due to legal uncertainty or lack of information about the damage extent. And moreover, if the risk profile of a company is impaired, the abnormal returns might shift downwards continuously in the long term. Therefore, we extend our event window to 150 days after the event so as to fully capture the market impact. And we retrieved the most updated figures from Factiva regarding these 3 determinants. So first, we logged the variables in order to eliminate the effect of outliers, and then we used the multivariable regression model for these 3 determinants in order to test whether there exists some significant correlation between the severity level and the stock market reaction. Luckily, we do have some interesting findings. So for hypothesis 1, we used the CAR on day 0, day 10, day 50, and day 150 to represent immediate, short, medium, and long-term market impact. So as we can see, we first used all 3 determinants to run the regression. But as you can see from the p-value, actually, determinant 3 is not contributing significantly to the model. Therefore, we just, this is probably due to the missing or lots of missing or inaccurate data regarding these characteristics. Therefore, we kicked out this determinant and run a multivariable regression again with only casualties and amount of toxic release. So the F score has shown that the overall equation for the short-term and medium-term market reaction are actually statistically significant at 5% and 1% level respectively. However, for the immediate and long-term equations, they may be result from sampling errors. And then we can check the correlation coefficient of specific determinant. As we can see, the toxic release is negatively correlated with the short-term market reaction, while both of the determinants have negative correlation with the medium-term market reaction. So this has generally confirmed our hypothesis. However, as you can see, the immediate and long-term market reaction, neither of the determinants has such negative correlation. Therefore, it rejects our hypothesis for these two time periods. So the next problem is why this happens. As we can see, for the immediate market reaction, lack of information may be the main reason. So on the very date of the disaster occurrence, information may not be available regarding the accurate number of casualties or the exact amount of toxic release. Therefore, the results is not significant. However, as the investigation results come out gradually, we can see investors will have a more complete picture regarding the severity level of the incidents. Therefore, the short-term and medium-term reactions are negatively correlated with the severity level of this case. And for the long term, accumulation of confounding factors may obscure such correlation. But does this mean there is no market penalty in the long term? I don't think so. Because for severe chemical cases, irresponsible company could still suffer in the long term. Let me raise an example. So 3 months after the Deepwater Horizon incidents, BP has lost more than 1/3 of its share value. And this incident not only cost BP 14 million to clean up the oil spill, it also aroused continuous claims from various stakeholders, such as fisheries, tourist agencies, and even the Wildlife Foundation filed some claims against BP. Therefore, our findings for this hypothesis generally provide some economic incentives for companies in the related industry, especially the oil or chemical industry. If the company can seriously consider these potential loss in their share value, they may have more incentives to take more preventive actions to prevent the occurrence of chemical disasters. So I'll invite Miki to elaborate more on our findings of the other two hypotheses.
Okay, regarding hypothesis 2, after dividing the CAR into the developed group and the developing group, we can see there's different reacting trends from this figure. First, I will want to highlight some specific points in this figure. Although at the event date, the CAR of the developing group is much more negative, but subsequently, the developed group experienced a significant slump, and which is more severe than the developing group. And both of them are associated with a reversal after the mid-run. So relating back to our initial estimation, the investors tend to react more negatively for the events occurred in developed regions because of considerable and continuous news released during the short and the midterm. And this comes from our hypothesis 2. Our results also provide more insights on the market reaction. Due to the reversal you can observe here, the investors tend to overreact to the chemical disasters in the different time periods and also in the different events occurred in different regions. So let's come to hypothesis 3. In the short term, you can observe from this figure, all of the companies incur negative effects. However, the CAR of the group with government intervention tend to reverse in this period and stabilize subsequently, while the CAR of the other group without government intervention shows a continuous decrease and is consistently below than that group. So you may wonder, what's the reason for these trends? We expected that the damage cost, it may be partly bared by the government. So the government intervention may send a positive signal to the market that they will improve faster the disastrous situation. In addition, the unexpected costs associated with the government intervention may be smaller compared with the anticipated damage costs or the firm's earnings. So on the other hand, if the government do not interfere, the companies may be reluctant to take any remedial action, and the investors may take a negative attitude to this fact. So, based on our analysis, our hypothesis 3 is rejected by this figure. Now I will invite Blue to give you the final conclusion of our research.
Well, overall, our study has examined 30 cases with 30 global chemical disasters. And after screening out this non-contributing determinant, our first hypothesis has suggested that there is significant negative correlation between the severity level of disasters and the short-term as well as the medium-term market effect. However, in the immediate term and long term, our hypothesis is rejected, but this overall hypothesis has provided some economic incentives for the companies to take more preventive actions. And also, we found another interesting finding is that for chemical disasters happened in the developing countries, there is an immediate overreaction. However, probably due to the greater media coverage, cases happen in the developed country do not show an immediate overreaction, but rather a short and mid-term overreaction. And thirdly, because generally after the chemical disasters, most of the firms suffer from the decreasing share value. However, those companies with government intervention might recover in the mid-run. Therefore, governments should intervene in time for those severe chemical disasters in order to protect the interest of public. However, our study do have some limitations. The first one, actually it is quite difficult to retrieve accurate information or figures regarding the historical chemical events. Therefore, this has resulted in a relatively small sample size. And secondly, considering the various properties of chemicals, it seems quite inappropriate to use only the amount to measure the level of severity. And thirdly, accumulation of confounding factors in the long term, this may lead to some misleading implications. Despite those limitations, our study indeed provide a new angle to quantify the severity of pollution instead of merely considering its occurrence. And we hope future studies could integrate some multidisciplinary knowledge and develop a more comprehensive approach to measure the severity level of chemical disasters in order to provide more responsive and accurate conclusions. That's the end of our presentation. Thank you for your time and attention.